Okay, so as I will try to do with most of the problem sets that I give you, especially this one being the first one, I will do one of the problems with you and hopefully give you enough inspiration to work through it the way I've shown you. Okay, so this is packet 1, and it is speed, velocity, and acceleration. The setup for this is actually the same way that I showed you in the tutorial about problem solving. Here's an example problem here, writes out what the problem is, but once again we have our givens that are taken from the problem here. We have an unknown that we're looking for. This is the equation that we're going to use in order to solve it, and this is the solution. Okay, so it's slightly different setup, but it's still the same components that we're using. But still, we'll use the graphic organizer that I said, and hopefully you guys will get a chance to get more familiar with that as we go along. You are on this right here. Your version of it is electronic. Unless you have a printer at home, you can't print it up. Okay, so just use the electronic version. Write it out on a piece of paper. You'll submit the piece of paper to me, a picture of it, and that will be your homework. Okay. Anyway, so what we'll do is we'll take a look at this first one right here. There's 8 problems in this first set that you will need to do, and there's kind of a combination of accelerations and velocities that are in here. All right, so this is the reason why we have to use the givens. Write down your givens so you know exactly what we're going to be using in order to find this. Okay. All right, so here we have exercise 1. Hans stands at the rim of the Grand Canyon and yodels down to the bottom. He hears his yodel echo back from the canyon floor 5.20 seconds later. Assume that the speed of sound in air is 340 meters per second. How deep is the canyon at this location? Okay, and then you would do your work right here, and then you would write your answer down there. But in this case, what we need to do is use our graphic organizer to do this. All right, so as you label your piece of paper, make sure you put a label on the top. So this is packet 1. Okay, packet 1, and it says it on the very first page of the PDF that you have. You can write down speed, velocity, and acceleration up here as well. Also, always have your name on these things. Okay, so that is mandatory. Make sure you have your names on these, because when you go on to college, you might not have this platform. Many of colleges do use this platform, but you might not have this, so it's always a good idea to get started this way. Okay, all right, so problem number 1, and we're going to start off, like I said in the tutorial, we're going to start off with making the first parts of our boxes here. This is going to start with our givens, and I used a colored pen when I did the other one, but that's okay. You don't have to use colored pens. You can use pencils. I don't care what you use to do this. Don't use crayons though, because crayons are kind of thick, and then you're using an entire page to do one problem. Okay, so our givens. We're given a time, and this time is he hears his yodel echo back from the canyon floor 5.2 seconds later. Okay, all right, so time that it took from the moment he said something to him hearing it back is 5.20 seconds. Let's see, assume that the speed of sound in air is 340 meters per second. Okay, so that's the end of my givens. I don't have any other numbers that are given to me here. So I'm going to finish that part there. And what I'm looking for, the equations I'm going to look for here, I'm looking for distance. Okay, if you remember the equations that we talked about in class, velocity equals distance over time. This is an average velocity here, so it's going to be distance equals velocity times time, and this will be distance final plus distance initial. Well, our distance initial we're going to say is going to be 0. Okay. Now, one thing that we got to look at, what is this echo doing? Well, it's what's this yodel doing, I should say. The yodel is going down to the floor and then it's bouncing back up. So how much distance is covered? Well, we're asked how deep is the canyon floor? Well, it went down and then came back up. So this is where we have to use critical thinking. Our final answer to this for depth of the canyon is going to be 1/2 of d final. Because what we were talking about is it coming down to the ground, hitting the ground, bouncing back up, so it's twice the distance. So we need to use 1/2. That's going to be our final answer, but to work it out, we need to use this. Could you put it all into one? Yeah, you could put it all into one, but if you put it all into one, then it becomes, it could become very confusing. Okay. Now, as I mentioned before, this could be a reason why we do a drawing of it right now. So I do a drawing here. I have the canyon here. Okay. And here is Hans, you know, the little stick figure guy right there. And Hans is going to yell down. So this is his voice yodeling down, coming down to the bottom here of the canyon. And then, you know, I'm just going to change the color here so it comes back up. And we see that it hits his ear right there. So here what we're seeing is that it travels down and then it travels back up, so twice the distance. So hopefully I got that across to you. Okay, so I'm going to close on that side there. So here we've got seconds and seconds. We don't have any conflicts with units, so we can go ahead and just dump them into this distance final equation. So distance final equals, and like I said before, I like to use dimensional analysis for just about everything, and I don't know why my pen's acting up here. Okay, so velocity is 340 meters per second. And the speed or the time is 5.20 seconds. Now, could I use 2.6 seconds? Yes, you could, but you show your work. Just don't all of a sudden put out magic numbers, okay? You have to show where you got your numbers from, okay? So if I use 2.6, I should have done this, but with time first, and shown my work there. Okay, but this is going to show us our total distance that it traveled up and back. Okay, so seconds cancels with seconds. Okay, so I'm going to be left in meters. So then my d final is going to be equal to, I grab my handy dandy calculator here, and 340 times 5.2 equals, and I get 1768. So 1,768 meters, but remember that's double the distance. So now D equals 1768 meters divided by 2. So our final distance that we're going to have, we just take our answer and we divide it by 2. We get 1884. So 884 meters. That's 0.88 kilometers. Okay, and we can easily take that and change that into miles if you need to. 1 mile is 1.6 kilometers. Okay, 1.64, something like that. And so that means that we are looking at about half a mile. Okay, so this is our distance right there. Okay, now we close our box and then we move on to problem 2. All right, so there you go. There's your first problem, and good luck with the rest of them.